Hello and welcome to this fifth episode of a Base Builder tutorial series. And this time we will be working on visualizing our entities. So last time when we left, we finally were able to show something on the screen. We were able to show the world and show it being changed when the jobs were completed. This time we're also going to show the actual workers doing the work. So to do that, we will create a new class, an entity sprite manager that will be somewhat similar to the tile sprite manager. It will be responsible for caching sprites as well as nodes, and it will clean up entities that are no longer in the world. So for instance, an entity might die or leave, and something else might happen to them where they're no longer needed in the world. And then we also need to make sure we clean up any sprites from the screen. We will add the entity sprite manager to the game scene, and we'll add the location requirements to jobs in the demo world, because then we can see the workers actually change locations. So let's get started. Let's start by opening the Xcode, open a base builder tutorial. So let's see. And let's start by creating our entity sprite manager file. Open it up. It requires SpriteKit, and it will be a class called entity sprite manager. It will conform to the sprite manager protocol, which means that it needs a cell size and it needs a Z position. And it will want a redraw function. But we need a few things more, because we said we're going to cache sprites and nodes. So let's create an entity texture map. This is a dictionary that caches the textures based on a name, similar to the tile sprite manager. We'll have an entity sprite map that maps from the entities. We'll use an object identifier, so basically the actual address of the object, or the entity object, and map to an SK sprite node. And we need an initializer that takes a cell size, and we need a Z position. That will also be a CG float, and this one will have a default value of 0. We'll set the cell size, and we'll set the Z position. And that's it for the initializer. So let's start working on the redraw world entity. So this, our logic is going to be sort of like, we'll go for each entity in the world of entities, and then we will set the entity texture for the entity in the scene. And this is a function that we need to write. And after that, we will call a cleanup function, where we make sure that any entity that's no longer in the world also gets cleaned up from the screen. I'll create the cleanup function first, because it's simpler. We'll have a function called cleanup. It'll take the world, and it will start by getting a list of object identifiers from all the entities in the world. So we're not interested in the complete entity, only in the object identifier, and we get those by taking the entities in the world and mapping them to the object identifier. So now we have an array of object identifiers, We also need somewhere to store entities that we need to remove. And this will be an array of object identifiers. And this will start off empty. And then we go through each entity ID in the entity SpriteMap.keys. So basically what we're going to do is we're going to look through this dictionary, look at all the keys. And what we want to check is this key something that's still in the world as an object identifier? This needs to be capitalized and singular. So what we'll do is we'll say if object identifiers dot first, where the object identifier is equal to an entity ID, and this one is nil, so we can't find any. And we'll say entities to remove dot append entity ID. We can't remove them here directly because we can't mutate this dictionary while we're looking through it. So that's why we need to store the entities to remove somewhere else. But this should give us an array of object identifiers pointing to entities or pointing to entities that can be removed. So let's go through those. For an entity ID in entities to remove, let's say entity SpriteMap entity ID remove from parent. So that gets us the sprite node, and we first need to remove the sprite node from the parent. And then we need to remove the value for the key for this entity ID. So we also need to remove it from the SpriteMap itself. And when we call this, then if an entity gets removed from the world, it gets removed from the screen, and it gets removed from this dictionary. So they're not leaking there anywhere. So getting back to the set entity texture, and this is the one that will really show the entity on the screen. So we'll have an entity texture. This will take an entity in the scene. And we first want to get the texture. We'll use something similar to the one that we had in the Task Sprite Manager. So we'll create a function called getTextureNamed, and this will take an entity. And we could use the name, but I'd rather use a specific sprite value. And the reason for that is, let's go to our entity. Say you want entities to have different names. So they could be called worker123, or they could have names like Jane Doe or something. But then if you use the name to point to a specific sprite, then that requires having sprites for each and every single name. And I imagine that you would have many more entities with perhaps different names that share similar sprites. What we'll do is we'll add to the entity an additional property. We have a position here. I will say let sprite. This will be a string, so it will more or less be the sprite name. And we'll, in the initializer, we'll add, if we can choose this pass in a string for the sprite. If we don't, then we will default to using the name. So we're passing in an optional string for the sprite. If you leave it blank or you put in nil, then it simply defaults to the name. If it's not nil, then it will use the name you pass in. So now we can go to Entity Sprite Manager, and we can say we get texture named for entity.sprite. Let's create this function, and this one will cache entity textures. Function get texture named. This will take a texture name. This will be string. We'll return an escape texture. That's really similar to the Tile Sprite Manager one. So if we have a texture already in the entity texture map, we will return the texture. Else, we'll create a new texture based on the image name, texture name. The entity texture map will add to it this new texture, so that's adding to the cache, and then we return the texture. So now we should here have a texture. We also want to have an entity ID that will be the object identifier for the entity. And then we'll see if we already have a sprite node in the entity sprite map for this entity ID. Then we say the node.texture will be the texture, and the position will be a new CG point for, and we need to cast this to a CG float, the entity.position.x times cell size. And for the y, we need entity.position.y and cast it to a CG float times the cell size. So this updates the node's position. If there is not yet a sprite node available, then we need to create a new one. So we'll create a new SK sprite node with the texture. We'll set the size to be a CG size, the width cell size, and the height also being cell size. We'll set the position, well, that's actually the same as this one. We'll set the Z position to the Z position that's passed in for this sprite manager, and we'll give it some user data. We'll give it the entity ID. You can look it up later. We'll add it to the scene, and we'll add it to our cache. So to our entity sprite map, the entity ID will set to node. This should be enough, at least the minimum required to show an entity on the screen. In our game scene, we now also need a Tile Sprite Manager. I'm sorry, we need an entity sprite manager. The Tile Sprite Manager already has. We'll create a new one here. We'll give it a cell size, and the Z position will be 0.5. And then in our redraw function here, we can say entity sprite manager.redraw world in world. And as the scene, we put in self. I think this should build. This should also run. So we can at least see an entity here, but we can't see the entity moving yet. And the reason for that is that these jobs it's performing here don't require a location. So just to be able to show a bit more, so say we have our jobs where we change the tile to walls and floors. We'll add a couple of requirements. So for the requirements, we'll put in a position requirement. So let's run it. Now we can see it's moving to where it's performing the job. It's also slower now, but that's because it also needs to perform move to location jobs to be placed at the correct location. So what we will notice that once we add more and more requirements, actual building will become slower. And you might need to compensate for that with either the build times or how many updates you do per second. But this seems to be working fine. This is looking good. Now it's done. It can stay there. Close this. I want to do one final thing, and that's we have the entity sprite manager here. We added this cleanup function. I think the cleanup is very important to prevent memory leaking, so I'll make it a part of the protocol. So for the sprite manager protocol, so that means that all objects that implement this protocol require a cleanup function, meaning that we always need to look or we always need to think about cleanup. So our cloud manager no longer conforms to the protocol. So we'll create a function called cleanup. But we don't actually have to do anything here because for now we assume that tasks never get really deleted. But this way, at least, we are very explicit that we thought about this case. So again, we should be able to run this and the results should still be the same. So it's still working nice and hard, building those walls, flooring the wall, moving around. Pretty cool. So I'll let this guy complete the job here. Let's go back to the overview. So we have we're done visualizing entities. And next time we'll visualize items, and after that we can do some more, some different stuff because visualizing items will be very similar to visualizing entities. Thanks for watching and have a good day.